We are starting with the meetup for Container Talks powered by Devtron. We have two interesting speakers here today. Uh, we have Mahesh Jadhav and we have Shivani Bhatt. And I will let them introduce themselves and uh, go further with that. Uh, let's go with that.
Hello guys, my name is Mahesh. I have around a decade long experience now working with all of this stuff. Most of the time I do daydreaming. Sometimes I write code and sometimes also I read books. But most of the time it is daydreaming. Like most of the software engineers do, right? Daydreaming. Just looking at somewhere and thinking on something else. That's it. That's it. That's my job in general. I have led. I was working as a researcher in Government of India. I have worked on. I've worked on location intelligence. I have worked. I haven't worked in organizations like Whitney Bose and Schlumberger, and I have designed the complete gameplay in Dream 11. And before this, I used to lead the complete engineering section in Zepto. Currently, I'm working on my own idea. Norimos, it's in social commerce and group buying. I'll also post you guys with the link after this. Feel free to visit. Right. So today we will be understanding what is DevOps and the journey of DevOps in your organization. Right. How the journey should look like for a DevOps system, or I would say culture, right from the start of an organization till the point it is perfect, it's picture perfect, right? If you notice what I've written, dev and ops as two different words, right? So DevOps is not a single word, it is combination of two words. One is developer, other is operations. And if you can see, both of them are holding two torches, right? One is red, which is development, other is orange or amber yellow. Yeah, on my screen it is amber color, right? Which is of operations, right? And when we combine these two terms together, it forms DevOps, right? Now, in this particular session, there will be a couple of questions we'll try to answer to ourselves. First is, what is DevOps? How did it
Mahesh,
all
Mahesh,
start?
Mahesh, Mahesh. Sorry to cut you in between. Let's continue with the introduction first, and then we'll go. Let Shivani introduce herself, okay? And then you can take over the screen instead of all three of us sharing the space.
Okay.
Yeah. Hi. Thanks you, Swapnil. So I'm Shivani Bhatt. I am a software developer at Devtron. I have a total of 2+ years of experience in Devtron only. So I basically started my journey from here, and whatever I have learned is just in Devtron only. And apart from this, I just love doing shopping. I love roaming, and I love photography. This is all about. So yes, now on to you. You can start.
Sure. Thank you, Shivani. Thank you, Swapnil, for the brief introduction about everybody. Right. Maybe we can start with the session now. So in today's session, we'll be understanding about the journey of DevOps. Right. If you see, there are two torches with two different hands. Right. These are the two pillars of the software development. Of course, there is QA pillar, but I consider it part of dev in general. Right. I do not differentiate between devs and QAs. Right. I call them as estate. So if you see the red color torch and amber color torch, both of them are holded by dev and ops respectively. And DevOps is not a single word, but it is combination of development and operation, right? So when development and operation come together and it forms a amalgamated culture, it's called as DevOps, right? So what are we going to what we expect in this session? In this particular session, we'll be answering what is DevOps, how did it all started, how do I do it, like what should I do it when I'm starting it up, and some things to remember. So I have not written what things to remember, but we will discuss them, okay, and then we'll have a chit chat discussion to and fro on those things. Okay, so moving on. So you must be thinking, right, when actually DevOps started, because DevOps appears to be a very relatively new concept, right? So how did it all start? So this was a life before DevOps. So there was a dev, there was some wall in between, there was operation, and then basically they used to deploy, the operations used to deploy what dev has developed. Okay, and this was in olden days when there was hardware systems on, and like VMs on which we actually used to do manual deployments, right? There used to be racks in server rooms basically, which used to buy servers off and basically used to go deploy. So the system admin team used to actually literally copy and paste your deployment via maybe pen drive or network channel or something like that, or maybe USB disks or something like that, and basically make a deployment. It used to take a lot of time, right? And it used to need a lot of coordination. Okay, but that time cloud was not that much in boom. This is back in 2000s when there was internet boom. Then the dot-com bubble, I would say. Okay, the dot-com bubble was expanding. So generally there should be dev, everything built karke, dev has given out basically, and there is ops. Okay, there is ops, and in this ops basic, the job of ops was to maintain all of the systems and deploy whatever dev supplies with all of the instructions which were supplied, right? Most of the time it used to end in disasters. Like if you have if you remember, in when we were young, I would say in school or something like that, right? So Yahoo used to go down when there was a new deployment, right? It used to be out of service and there was something like the site is unreachable label, or under construction or under maintenance label, and then basically there was a deployment which used to take like a couple of hours, and that used to happen, right? The system admin used to go and manually deploy it. So this was what used to happen in olden days, life before DevOps came into picture, right? Sorry for the not used of camel case in case of DevOps, right? But yeah. So today, how many of you guys actually use Netflix? Can I interact with people over here, or it's just one-way streaming?
It's one-way streaming, Mahesh, and we are not able to see your screen.
Is it visible?
No, not yet. See this. We still don't see your screen.
I have already shared my screen. Do you want me to share the complete screen? I'll do that also. See, I'll share
Yeah.
it again. Is it visible now? Hello? Is it visible?
Yes, yes, it is visible.
Swapnil, can you confirm, please?
Yes, yes, it is visible now, Mahesh.
Visible, right? So yeah. So this was back a small animation which I had done. How things used to go. Okay. So after this blast, there used to be a lot of cover up operation, and then basically system used to be stable just till the next deployment. So today we take services like Netflix, Amazon, Google for granted, right? Because they're always up, right? But what makes these services possible? It is the ability to make hundreds of deployments per day, right? You 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 may not be surprised, right? Netflix in general makes like hundreds of deployments a day. Even Amazon does it, right? There are so many features and there are so many hundreds of microservices. Each of these services is deployed at least twice or thrice in a day, right? With new features coming in and all that stuff. So can you imagine a world where you can actually just have one deployment a month, or maybe just couple of deployments a month, right? That was the reality back in 2000, and that was in the golden days of waterfall methodology, or what do we say as a waterfall model, right? Why we used to call it a waterfall model? Because it had steps like waterfall has, right? And we used to follow those steps, and at the end of the at the end basically the water used to fall on the riverbed. Okay, and the steps were executed. Yeah. So the software was developed and tested for months before it was released, and the deployment would be done by ops team. And then basically ops team used to make a deployment, then used to do rolling restarts and all that stuff. And then basically they used to stabilize the system because it used to create a blast radius, and then the fun used to begin, right? Because everybody used to try to actually make a disaster, execute the disaster recovery plan, and get back all of the systems up and online and working. Right? This used to be life before DevOps. Okay. Now let's go back to the history of DevOps. Okay. So, precursor in early 1900s. Okay, now you will think that why we are going early 1900s, right? Early 1900 was not the age of computers, right? But let me tell you, DevOps started with something which was revolutionary in the manufacturing sector, right? So, a lot of practices in today's world we have inspired it from manufacturing sector. I'll give you an example, like standardization. We actually learned it from manufacturing sector, right? Then basically creating containers, we learned it from manufacturing sectors. Then basically reusable parts and conveyor belts. We have reusable parts and reusable services, right? We learned it from conveyor belts and conveyor modules and CNC machines from the manufacturing sector. So early 1900s, when manufacturing industry flourished and there was mass manufacturing of automobile, which has picked up very sky high because oil was cheap, right? Toyota came up with its own concept called as lean manufacturing. Lean, like me, I am also lean, right? Very lean, okay, very efficient people. We can run for miles. So lean manufacturing goal was process optimization across the manufacturing floor. So this methodology was centered around continuous improvement and encouragement. Okay. So what were the key points which this lean manufacturing used to take care of? It used to keep inventory at minimum, because see, inventory comes with a cost. Both raw material and finished products waiting to be shipped. Minimize the order queues, right? So the manufacturing process, they made it so efficient that there were no orders in the queue. The waiting time was very less. So order received would be immediately moved into fulfillment, right? And it used to get shipped. So that is how car manufacturing was automated, right? Maximize the efficiency in manufacturing process. So there were robotic arms. Then basically there was spray paint machines which came into picture, conveyor belts for moving parts, and cranes, robotic cranes. All of these things came into picture. So, do you find any similarities in DevOps with this? Actually, yes. DevOps also does the exact same thing, just it does for software industry. What it does is that it automates what we call it as builds. It automates what we call as deployment. It automates something called as testing, right? Instead of spray painting, it is validation and verification and validation using various test gates, right? When we add PaaS, that is platform as service, infrastructure as service, cloud, and agile methodology, then we call it as continuous integration instead of continuous improvement. In manufacturing industry, we used to call it as continuous improvement. Today, we call it as, in software industry, we call it as continuous integration. So how did DevOps came up? So like कहाँ से आया ये टर्म? Like DevOps ऐसे ऊपर से तो नहीं आया. In 2009 at O'Reilly Velocity Conference, there was a guy called as John Allspaw. He was like SVP of Technical Operations, and Paul Hammond, the Director of Engineering. Both of them gave a presentation on 10 deployments per day. Try to understand, in 2009 it was just 10 deployments per day. That was revolutionary, right? And then it said that dev and ops cooperation at Flickr. Okay. Now, these people from Flickr actually revolutionized the industry by making 10 deployments a day, right? Somewhere in this conference, the term DevOps was coined, right? While mentioning the cooperation between developers and the operation people, they said that they coined the term DevOps, and that term landed in the engineering diaries and books, and we are using it till date, right? Now, back then also, DevOps was never a person, never a team. It was always a culture, right? It was like a amalgamation of developers and operation teams together, right? In this talk, they emphasized on why communication and collaboration between development and operations are vital, which sparked the appearance of what we know today as DevOps. Right? Right. So before DevOps, what used to happen? There used to be an ops person, right? There used to be a dev, right? And basically if something used to go wrong, then there, because there was to be very less communication, right? And something used to go wrong, dev used to say it's not my code, and operation used to say it's not my machines, it's your code, right? And there used to be continuous tussle between them because there was lack of communication, right? So DevOps addressed that issue of lack of communication between dev and ops teams. So what is the textbook definition of DevOps, right? Let's go to the textbook definition for DevOps. So my favorite character from Three Idiots, going his way, Chatur's way. I'll just try to sound like him. DevOps is the combination of cultural, philosophical practices and tools that increases an organization's ability to deliver applications and services at high velocity, evolving, improving products at faster pace than organization using traditional software development and infrastructure management processes. Perfect, right? Did I sound like Chatur? You tell me in the comments or in the chat window whenever you feel so. I tried hard, but my acting skills are not that great. So, where does it help actually? So, DevOps, it aims to maximize the predictability, efficiency, security, and maintainability of the operational processes. Just not dev, but the operational processes. It tries to fix the inefficiencies of the waterfall model, right? Why try to fix the inefficiencies of waterfall model? Because waterfall model was very widely used in back in 2009, 10, 11, and 12, right? 8, 9, 10, 11, 12, right? Back when we were in engineering and when we started our career early, at that point of time, it was very widely used. Agile was relatively new, right? So what fixes, what things did it fix, or what improvements did it make? It did something called as low failure rates for new releases, faster mean time to recovery, and shorter lead time between fixes and not fixes, because the release failure rate is very low and recovery is very fast, right? And the deployment time is very small. So if something goes wrong, we can immediately make a fix and deploy it as a hot fix now, right? So lead time is very low. High frequency deployments, very high frequency deployments, like 10 deployments per day is literally a very high frequency deployment, I would say, right? Coming from the model of one deployment per month, or maybe what couple of deployments in a month, from that point of view, I guess this is very on the higher side. So what positive effects does it have? So because the deployment time is very low and it doesn't need like months and months of testing, and in deployment is very fast, releases are fast, so shorter time to market, because now basically you have leverage to make mistakes, right? Even if you make mistake, you can immediately fix and deploy it, right? Without affecting the customer for a very long period of time, right? Improved customer satisfaction. Why? Because now your iteration process, now you're going from a waterfall model to iterative model, and you're making iterations rather than waterfall, right? Did you understand now from where the iterative model came into picture, right? So it improved the customer satisfaction now because the product was more improved, because because of just a small change, and making the deployment time small, the product quality improved because there were many iterations now which was possible. Improved productivity and efficiency, right? And then basically faster experimentation. Now you could experiment on things, right? Even if something goes wrong, okay, अरे deploy कर देंगे इसको थोड़ी देर बाद वापस, कोई problem नहीं है. Okay, so journey of DevOps in a startup. So let us say there's a person, okay, Isha and Preeti, and Preeti is talking to Isha. Preeti is running a full-fledged large-scale company, and Isha is just about to start up. So small conversation between them, right? So Isha says hello, Preeti says, and Isha basically replies back. Isha basically replies back, saying hello to Preeti, and basically what happens is that Preeti says that, how do I start up DevOps culture? Right? I'm about to start a startup, and how to start DevOps culture. So what happens is that Isha says that, sure, let me walk you through how to start and how does it progress as you grows, right? So now basically Isha is listening and Preeti is trying to tell her what and how basically the DevOps culture you have to ignite and how it starts, right? Okay. So in general, when you start a startup, when you actually start working on an idea, so in general there are only couple of people, maybe a tech co-founder, a business co-founder, a co-founder which is working, which is handling the product, or maybe two or three co-founders all from tech background or something like that, right? So initially I would say a startup in its pre-MVP stage, right? It is not yet deployed. Generally there are only co-founders. Maybe if you have some money in your pocket, you are from the upper middle class or maybe the rich class, basically you have some money, you can hire a couple of employees, maybe one or two early employees with lower salary for sure, right? In general what you have, okay, you in general what you start with, every application start with something called as monolith, right? And you just have one you sign up with AWS or Google Cloud, and basically you have a EC2 instance or a compute instance. Basically you have one VM. On that VM basically you save your code in Git, and basically you just log into that app server, do something called as git pull and deploy, right? This is the first form of deployment in any organization, right? So the fully automated deployment doesn't start at day one, right? Why it doesn't start at day one? Because you do not know what your applications are going to be, how the flow is going to be, what all things you need, right? So you do not know that, and that is the only reason you start with very simple and rudimentary. Okay, git pull and deploy, simple, right? Even when I started working in Zepto in initial days, we were just 5 or 6 people. It was just git pull and deploy, nothing much, right? As soon as you have your MVP ready and you do your testing, app ho gaya, testing shuru kar di, oh it's working, wow, bazinga, bingo, right? Eureka, you have your eureka moment. Oh, my product is ready now, let's go to the market. Okay, go to the market means you make a formal release or something like that, but it's still in single server git pull deployment. That should work, because why? You do not have enough users to get affected even if you make a git pull and deployment, right? Then basically you go to something called as early days of your startup. MVP is done, now your MVP is done, an application is in early market. There are definitely 2 or 3 early employees now. By the time basically there are some users, you have some user base, maybe couple of hundred or hundreds of users, right? Maybe couple hundred users, and you have 1 or 2 or 3 at least employees. There are releases, but they're not that frequent. Why? Because you have only 2 or 3 people, right? How many, like, you're going to, one of them is going to make one of them is going to make front end, other is going to be work on the back end, one of them is going to do testing, and then basically all of this cycle ends and then you make a deployment. So they are very infrequent, they're not that frequent, right? But at this point of time what happens is that your team says that git pull and deployment is not working for us, right? Then your team comes up with something with very simple automation, only build. Instead of doing running all of the build script manually, what you do is that you maybe install, किसी को Jenkins पता होगा, or maybe there are tools like GitLab, AWS Zero DevOps. You use one of these tools basically and just have a simple build, and then very simple deployment, manual deployment. Okay, it's manual deployment but still deployment process, right? Then you say that how can I test on production if I'm making a feature? So you have a separate test environment now at this place, right? So you have a source code, you build, you use tools like Jenkins and GitLab. There are other tools also, guys. I do not know all of the tools, so whatever tools I knew, I have used it. I have just mentioned it over here, right? And then basically you deploy it on the same app server. Okay, there is only one app server. On the same app server, there's front end, there is back end, and of course there is database. Nowadays basically you do not need to actually install database. There are hosted database available like RDS, or maybe Cloud SQL in Google Cloud, or RDS in AWS, something like that, right? After these days what happens is that you move to the next part. Now basically your company is growing week on week, there are new users coming up, right? You move to the next level, and now this simple build and deployment process on the single server It's not scaling, it's not working, right? And you're feeling the pain, your employees are feeling the pain. The tech person, the senior tech person from your organization now says that now it's time to introduce something more revolutionary. Okay, now we are into the next stage, what we call it as in the market stage. The product is in early market now. We have now a couple of folks because your company has grown up a bit now. There are 10 to 12 employees. You have one maybe one or maximum two people who are actually working on ops, and you start calling them as operations team. They also do the monitoring part, deployments and monitoring part, right? Now what happens is that now we have moved to a centralized version control. Okay, before this it was simple, but now it is centralized version control. There are also changes which you make to database. Now what your ops team says is that you tell us what are the changes, we'll make it, we'll run those scripts after your testing is done, right? Then basically your tech member says that let's introduce automated unit test cases in at this stage, at this point of time. Why? Because as you have automated test cases, it builds up your confidence, right? And these are unit test cases, these are not like full-fledged integration test cases and simple unit test cases, right? You have a separate environment for dev, you have a separate environment for QA, you have separate environment for staging. Now your deployment process is defined now, that these are the stages you need to pass. This is the environment one, this is the environment two, in which you're going to test for these xyz things. Like let's say you're going to do smoke test and all that stuff. Then basically this is another environment you're going to do load test. And then basically there is a staging environment, or we call also call it as pre-prod environment. And then basically it will go to production, right? So you're, because you have an ops team now, you have a well defined path to follow, right? You have a set of application servers, because there is less space. I haven't actually shown multiple servers, but there are now multiple there is a set of servers on which you deploy, and there is a load balancer, probably load balancer, something like that. So now you understand the infrastructure is also maturing, right? Because you are scaling up, your number of requests are increasing, right? So this is the early stage, but now you're in the market, right? Can you see the maturity of the ops now, right? The journey of the ops, right? Now you have started surviving in the market. You are hustling and bustling and you're surviving the market. You are seeing exponential growth. You have a growth phase now. I'm assuming you are in a successful startup, right? You have 20 plus people now in your engineering team. The boundaries between dev team and the ops team fades away a bit. Why? Because the ops team is also writing a lot of automation now, right? And they get started involving as soon as the team start building the feature or start building the service. Mostly you start focusing on agile development and iterative models rather than waterfall model, or maybe iterative model. You go into pure agile methodologies now. Builds based on polling instead of manually triggering the builds. Now basically as soon as there's a PR merge or something like that, you keep on polling the Git APIs or maybe any source code control APIs you have, and basically your operation team says that automatically build will happen as soon as it is merged to, let us say, main branch or master branch. Main branch I'll say, because they have changed it now. Now basically what ops team has done is that initially if there was something bad used to happen and you need to revert back, you actually had to revert back your code and basically make a full build and deployment, right? But now what ops team has come up with, that something called as tagging, right? And any build can be recreated from the source. Okay, any build in the history can be recreated from the source because they're tagging now, right? Build artifacts come into picture instead of plain builds. Now build is created in the form of artifacts into smaller components, right? It's still painful, but less painful than the previous ones, but it is semi-automated and the releases are reliable. Like, because the releases are the builds which are actually tested, the same build which is actually tested, as the builds are immutable now, which is actually tested, is released on the production, right? So they are reliable, and basically you have some config management tools in picture now, right? DB migrations are version script. Now you start storing your DB migration in Git repos, right? And you have scripts, version script for them. Your ops team is running them manually, but they're still version, right? And they're incremental, right? Automated integration test and static code analysis come into picture now, right? Now you have integration test, you have static code analysis, you have security analysis on this picture, right? So can you see now a version DB migration script has come into picture, right? And you run on the database. Now after this, basically you have now, you are now into an exponential growth. Now basically what happens is that now you are into a something called as a mid-sized organization, where you have like maybe 50 60 strength strong engineering team, and basically you have good set of users and you have good amount of scale now, and you do not want to risk anything which should go like, you do not want to risk a deployment or any deployment or anything which should go wrong into the production, right? You want to basically mitigate all of the most of the risk, and basically you want to reduce the blast radius, right? So this state is something called as the next part of the managed state, right? Now, so there are no boundaries between dev and ops team now, because they work hand in hand. As soon as the service development starts, okay, the dev and ops teams are involved. Okay, you're making a service. Okay, you have a service which you are deploying in Java. Okay, we need a image of Java. We need a container image of Java. That's fine. Okay, then you want Java 8 for this, or maybe Java 11 for this. Okay, you want XYZ for this, XYZ tools, XYZ artifacts for this. Now builds are based on hooks. They are not pull now. They are hooks, right? Commit hooks. And then you have various build gates. Like if the integration test fails, build fails. If the let us say unit test fails, the build fails, right? If the XYZ test fails, the build fails basically. If the code analysis fails, the build fails. If there is, let us say, Sonar Cube, which you have, which you have for static code analysis, if that doesn't pass, basically the build fails, right? Okay, and only all of the, if all of these gates are passed, basically it will allow you to get into the it will allow the code or your releasable artifact to merge into the master and basically form a build artifact. The releases are push button to all of the environments, right? And they're fully automated now, right? And suddenly your operations team was thinking that manual running the version control, manual running the script on database can be very tiring, can make mistake, prone to mistakes. Why? So human tendency is to make mistakes, right? No human is perfect in this world, right? So we tend to make mistakes. They're not conscious mistake, but sometimes subconsciously, maybe instead of running version v2 script, I ran version v1.9 script. Something like that happened, right? Even with very strict policies, very strict processes, still mistakes do happen. So let's, instead of relying on humans, let's automate that. So there is an automated version DB migration with the help of tools like Liquibase or Flywire, right? And then basically the complete deployment pipeline is traceable where things are stuck, right? And reporting and release notes. There is reporting for each and every step of releases and deployment, and there are proper release notes and release artifacts which are created, right? Then how this is achieved? The automation is mostly achieved using tools like Ansible or CloudFormation, right? Then basically there is also something called as reporting and monitoring, which is in generally uh, uh, which is in generally achieved by using technologies and tools like Neuralink or Datadog. You also have your own open tracing stuff, but I prefer using already developed SaaS technologies, right? Because see, why you want to reinvent the wheel? Because your focus is more on uh, feature and product development rather than focusing on how I can best monitor this, right? Because there are already experts which are working on that. So something like that, right? So these tools come into picture. Now basically what happens is that you have survived the market and you have faced all of the ups and downs, and now you have sustained. Now you have like hundreds of engineers or thousands of engineers working with you, and there are simultaneously parallel features working, parallel features getting released. There are hundreds of microservices now, right? So for This kind of state, we call it as now your organization has grown bigger, right? Okay. Now there is something called as cross team continuous improvement. Okay. Now each team has its own standardized process. The code base is always deployable, right? Because there are so strong and strict gates available now. Whatever deployment you make, it is not going to break the production, right? Generally blue green deployments, right? So what happens is that when there is blue green deployment, you can also make deployment at broad daylight. It is not going to affect the consumer or customers at all. Most of the time, if you implement it well, implementing blue green deployment is again itself a challenge basically. But generally, it takes some time and effort to achieve a proper blue green deployment. Perfection, you cannot have perfect blue green deployment for sure, right? But some degree of perfection can be achieved, like a large degree of perfection can be achieved, I would say, right? Then you have canary releases, and they are frequent and fully automated, right? Feature is ready, let's go to deployment. All tests are done, let's go to deployment. Deployment is disconnected from releases, right? You can have that feature deployed, but the release to the customers can be done later. You use tools like you use something called as feature flags, right? You use something called as tools like I would say Firebase, maybe CleverTap, and all these tools. They will enable you to control the exposure of the user to the deployment, right? You can have a percentage wise traffic route, or maybe a conditional traffic route to the newer deployment, right? By this time, basically, now we will say that okay, that's fine, your deployment is fine, but I still need to create the infrastructure, right? So the infrastructure is also automated in this case now, using tools like Terraform, okay, or maybe Cloud Formation, or maybe any other infrastructure as code tools, right? And the environment provisioning is also automated now. You can create any number of environments for any number of purposes. Of course, if you create hundreds of environments or tens of environment, it's going to cost you a lot, but you can create it dynamically and automatically now. Then there is real-time tracking now, where what release is and what artifact build artifact had what kind of releases, and on what version it was deployable, right? Okay. And individual teams are responsible for releases, right? Instead of just the ops team, basically now individual product teams are responsible for releases of their own product, right? They just need to maintain the compatibility and standard and follow the standards. Okay. But this is not the destination. Yeah, I'll tell you why. This is, we feel, yeah, we have done a great job, but this is not perfect. Why? See, let us say there are 4 different services which are dependent on each other. What is going to happen in this case? I need to still make a very well coordinated deployment so that nothing breaks. In case of rollback of deployment, in case something goes wrong, if I need to make a rollback, I still need to make a very well coordinated rollback. Even if it is automated, I need to be present over there and basically understand what is there. And the person who is making the deployment, of course, he need to be aware of the release for sure. But that person also need to be aware of the complete system and their interaction, right? So what is our destination now? So the destination for our deployment, for our CI and CD or DevOps process or DevOps culture is, it should be cross team continuous improvement. Okay, zero touch deployment. You actually do not need to go and make manual deployments or push button deployments in this case, right? As soon as something is built, there are various automation gates and it goes to the release queue. And then basically when its turn comes, it is deployed. Instead of rollbacks, there are rollovers. Instead of rollbacks, we'll have a rollover approaches. There would be release trains, clustered releases. Release train means multiple services at time. Clustered releases means multiple product features which are interacting to each other are released at time. Service dependency config. So there would the ops team will develop a framework which developer will use in its services, which will say that configuration, that which version of API and which version of product is compatible with with the current deployment. And on basis of that, The automation will decide how to roll back, not you, right? You do not need to decide that. Automation will decide that. You can also have partial releases in this case and partial rollbacks, and it is a business flow release, right? So you're treating your deployment as a fabric, right? It is not a, a bunch of server, but it is a fabric now. How you can achieve these kind of fabric based deployment, right? Either you need to either you need to have your own fabric deployment fabric, which will have to design, or maybe you can containers your app basically, and basically start using container engines like Docker Swarm, Kubernetes, or any other container engine, right? And then basically you are at the destination stage now. At this point of time, you are at a stage where your product team can make deployments for a business flow, not just a service, not just a product, but a business flow, right? And basically you can roll over or roll back a particular part of that business flow, instead of just instead of rolling back the complete business flow in some if something goes wrong, right? So this is the final and the ultimate maturity of the DevOps model, right? Now these are the steps we need to follow, right? So this complete process, or the all of these steps which you follow, you cannot reach to the destination at day one, because you do not know what your destination is, how much services is going to happen, right? This complete stuff is called something called as DevOps maturity model, and there's a standard set of instructions which you need to follow, and standard set of guidelines which you can follow, right? So again, credits to uh, a really good presentation over the internet, which I loved a lot. So this is a summary of what I had explained. Uh, this is a beautiful summary of it. So there are 5 stages of your maturity of your DevOps, right? DevOps culture, right? Uh, and you can basically vertically get into again 6 parts. One is organization and culture and organization. Initially, you will just have a teams organized on platform and technology, and you will just have a documented processes, right? In case of build and deployment, you'll have centralized version control, as we discussed, automated builds and scripts, no management of artifacts. There are no artifacts. Everything is manual. Environments environments are manually provisioned, right? Environments are manually provisioned, right? The releases are very infrequent, but they're manual. They're unreliable, I understand, because you're just starting up. You cannot have a reliable system at day one, right? The data management migrations are performed manually, and basically there are no scripts at all. You go, if there is a column which you need to add, basically you'll go there and add a column manually, right, using your SQL commands. Okay. Test and validation, maybe you will have automated unit test at this point of time. Some people from day one only try to have automated unit test basically. And basically you'll have separate environment test. Of course you need to have that before you go live. You should have a test environment, right? Information, you will have a baseline process for matrix collection, nothing else. Manual reporting, and basically a visible report. Unless and until you run the report around, you're not going to get the report of what is deployed and what's happening in the production, right? Then you go to this next state called as managed state, right? So in this state of your organization, you have you're into early market. You start adopting something called as agile methodologies, right? There are no team boundaries. You keep on pulling the Git or any source control which you're using, right? Any build can be created from the source code. Management of the builds and you have a well managed build and artifact managed builds and artifact basically. I'll give you an example. Like you have a artifact tree, maybe a JFrog artifact tree, or maybe a Nexus artifact tree, which is managing all of the artifacts. You have automated deployment scripts. Okay, you have an automated provisioning of environment. De- Deployments are still painful, releases are still painful, but that's fine. They're reliable now. Okay, the database migrations are versioned, but they are just scripts. They are manually performed. Automation, we have automated integration test. You have static code analysis, very basic version of SonarQube or something like that, and measure the process, automation, automatic reporting, and visible team. Okay. Now you go to the next step, that is called as defined, well-defined state, or we call it as defined state. You have extended team collaboration. There is no boundary between dev and ops. Basically, instead of polling, you are going to efficient mechanism like commit hooks. Build will fail on the quality standards now. Okay, you have gates for it. It is a push button deployment and release, semi-automated, I would say, standard deployment process for all of the environments, right? All of the environments are mirror of each other now. Infrequent but fully automated builds now. Okay, automated and version changes to the data store. You have, in case of test and verification, you're going to have fully automated functional test cases. So you have a very well developed section of SDET now. Okay, manual performance testing, of course, you're gonna have performance testing automated right from day one, right? Automate. Then for information reporting, you have very well automated generation of releases, pipeline traceability. You have complete pipeline traceability, reporting history, and visibility between multiple teams, what is happening, right? Then basically you into manage state, quantitatively manage state. Basically, in that, basically you have cross team improvements. Basically the individual product team is responsible to take his product to the production. The ops team is now building the platform instead of making deployments, right? Can you see the maturity over here? The team priorities keep the priorities of team is to keep the code base deployable, right? And builds are not left broken. Basically, you have orchestrated deployments, you have blue-green deployment, and deployments are very frequent now. And deployments are, what we say, disconnected from releases. You can have multiple deployments but just one release, and the releases canary, mostly canary, right? Changes to the data store are automatically performed by the deployment itself, like Liquibase and all of these are integrated in your deployment code base itself, right? Fully automated acceptance test. You have something called as UAT, user acceptance test, before it goes to the production. And basically there is no manual intervention for the deployment to go to the production. You can have a manual intervention for release, but deployments are not manually done. And basically you do your manual testing as soon as the release goes to the production. Of course, the functional testing. There is report and trend analysis, how the deployments are going on, what are the failure points, what are the pain points, basically, and real time drafts of deployments, deployment pipeline, where it is, how many deployments are going on, what product at what stage, basically, on that stuff, right? And the final destination which we have is something called as optimizing, right? You have cross functional teams, so you have completely removed the boundary between dev and ops team, basically, right? Ops team is also nothing but a development team which is maintaining the development fabric now, deployment fabric now. Okay. Zero touch continuous deployment, fully automated deployments. Instead of rollbacks, you will have rollovers, right? Automatic data store changes. You can verify the expected business values using something called as synthetic testing. Okay, as soon as it is deployed, synthetic testing will kick into picture, and if it finds any anomalies, basically it will do a full rollback, a partial rollback, depending on the configuration and the version compatibility of APIs, and it will basically alert you. Okay, and basically if there are any defect found, then basically it would be it will be ruled over, and basically it will ask you to make a hot fix if you want to make that feature work, still work, available for the users, right? And dynamic self-service of the information. You have customized dashboards and everything, and you have fully real-time monitoring, flow-based monitoring, right? So this is nothing but the overview of the complete discussion which we had, and how your system should mature in case of DevOps, right? So that's all, guys, I guess, with respect to whatever I wanted to explain. Okay, I'm opening the platform for any questions.